Hi everyone, this is us, group 10. We will present about our topic. Our topic is K-Trust Bridge. First, I will start with introduce what is K-Trust. K-Trust is a truss having in each panel two diagonals running from the ends of one post to the center of the adjacent post, the arrangement being symmetrical about the center of the truss. In simple terms, a K-truss is a type of bridge design that makes the bridge strong and efficient. It's like a puzzle of triangles that helps distribute weight evenly and makes the bridge stable. This design reduces the need for extra materials and making the bridge cost effective. It's also easy to build because of its special shape and it can withstand different kinds of forces like wind and earthquakes. Overall, a K-truss is a smart way to make bridges strong, steady, and practical.
My name is Nurshada binti Abdul Rosli. My metric number is AA232314. As critical components of transportation infrastructure, bridges must endure dynamic and varying loads, including vehicle traffic, wind, and seismic force. The incorporation of K-truss into the bridge addresses this challenge by providing redundancy, ensuring stability even when certain members are damaged or compromised. The dynamic nature of bridge loads requires efficient distribution mechanism to prevent localized stress concentration. K-truss excel in this regard, allowing for the effective dispersion of load, which is particularly crucial in regions prone to seismic activity. By facilitating the distribution of force, K-truss help mitigate the impact of seismic events, enhancing the overall seismic resilience of the bridge. Moreover, K-truss offer adaptability to changing conditions over the lifespan of the bridge. In response to evolving traffic patterns or the interaction of additional load, the redundancy in the truss design permits modification without compromising the bridge stability. This adaptability is essential for addressing the ever-changing demand placed on transportation infrastructure. A notable advantage of K-truss lies in the facilitation of maintenance and repair activities. Traditional truss design often face the risk of compromising the entire structure if a single member fails. K-truss, on the other hand, provide a more forgiving scenario. Damaged or deteriorated member can be identified and replaced without jeopardizing the overall stability of the bridge, contributing to easier and more cost-effective maintenance. Considering the long-term perspective, the cost-effectiveness of a bridge is a crucial consideration. The redundancy inherent in K-truss contribute significantly to the longevity and durability of the structure. This in turn can lead to reduced maintenance costs over the operational life of the bridge, making K-truss an integral component in achieving sustainable and resilient transportation infrastructure.
Then we will go to the basic theory. The K-truss is a structure system commonly used in engineering projects like bridge structures. It's characterized by a series of triangles that support the loads of a structure. K-truss members are top chord, bottom chord, and diagonals. K-truss are mainly used as bridge structures. In most cases, steel is the main material. However, timber could also be an option. The static system of the K-truss is characterized by having a hinge connection at all nodes and a pin and roller spot, which make the system statically determined. Therefore, the internal forces can be calculated with the three equilibrium equations. Next, we will go to K-truss with fixed connection. The K-truss with fixed connection has the differences to hinge connection. There are three differences. First, bending moments in the connections. Second, more rigidity greater than more robustness. Third, smaller vertical deflection. Next, K-truss with fixed and hinge connection. This is the most realistic static system, because of the top and the bottom chord might be delivered in one piece. meaning that they are constructed continuous and the posts and diagonals are attached to them. The rafters basically turn into a two-span continuous beam, which means that the static system is no longer statically determined. This means that advanced method of FE programs need to be used to calculate the internal force like moments, normal and shear forces.
This is the example of the real-life engineering application. This is the Long Island Bridge.
The general steps for calculating the load on each member are: first, verify the stability and determinacy of the structure. Second, determine the support reaction in the truss. Next, identify the zero force members in the system. 4. Cut the truss into two sections by passing a section line through the members whose forces are to be determined. Next, select a joint to analyze. Then, draw the free body diagram of one of the sections and apply the equations of equilibrium to determine the forces in the members. Last, repeat the process for the other section.
My name is Naashki Mentina Muhammad, matrix number 88230166, and I'm going to talk about discussion. So, in this study, we found that there is advantage and disadvantage of K-truss. Let's talk about advantage first. Firstly, K-truss reduces compression in vertical member. Second, it is possible reduction in steel and cost if designed efficiently. Next, its simplicity of erection and increased efficiency. Lastly, it reduces bending in horizontal member. Okay, next, let's move to disadvantage of K-truss. Firstly, it is slightly more complex than other truss. Next, it increases deflection and constructability due to an additional member. Next, a member can be in compression under one load scenario and in tension under another. Lastly, it is not popular as it is already lame. Okay, now let's jump into the conclusion. In the conclusion, the K-truss design stands out as a highly effective and versatile solution in engineering, particularly for the construction of bridge characterized by long span and substantial load-bearing requirement. Key to its success is the careful consideration of the K value, a parameter that likely play a crucial role in the design process, contributing to efficient load distribution across the bridge structure. Additionally, the utilization of high-strength material underscores the commitment to durability and the ability to withstand heavy load. Precision engineering is emphasized to ensure the structural integrity of K-truss bridge, reflecting meticulous design and construction process. Notably, environmental considerations are incorporated into the design philosophy, highlighting a commitment to sustainability in bridge construction. The adaptability of K-truss bridge further enhances their value, making them well suited for contemporary engineering projects with longer span and need for minimal support structure. Overall, the K-truss design encapsulates comprehensive approach that address both engineering and environmental aspects, positioning it as a valuable solution for modern infrastructure challenge.